Thank you. Hey, everybody. Yeah, I'm one of the co-founders of Revel. We like to call it a proactive observability platform, which I realize is kind of just like a made-up word that we created. And the reason we call it that is it's a combination of testing and observability. We focus on bringing features that Datadog has where you can do tracing and logging into your CI/CD pipeline and bring it kind of further left and combine that with testing, which I'll get to in a second. But the origin of our company, as he alluded to, we spun out of Uber. My co-founder created a project at Uber called DragonCrawl, which was a automated testing framework for their Android team. And the reason that they created this project, this was back in 2023, was that Uber gets all of their revenue from kind of one core flow, which is like booking a ride. And if booking a ride doesn't work, they lose $2 million an hour that it's down in production. So they needed a way to kind of bulletproof this user flow. And what they ended up building was this kind of, this was before LLMs were a thing, but they used custom embedding models to reason through the user actions and then try to book a ride. And this would just run like every 5 minutes. But the problems that they were facing was that the app was always changing, and this would break things like an Appium-based test script that is hard-coded based on selector IDs. If a new engineer pushes a change, it would break the test. You could imagine Uber has thousands of engineers, so that this would happen all the time, and they pretty much had no signal to noise with their test scripts. The other problem they faced was that Uber operates in a bunch of different languages and different cities, so that made testing hard as well. And then to kind of wrap this story up quickly is like all these things alluded to, Uber still up until 2023 ran all their QA manually. You'd think this is a company that is like at the top of Silicon Valley. They have all these engineers. They had a bunch of people overseas just manually trying to book a ride all the time, and that's kind of where they were at. So what they created was this project called DragonCrawl, which used actually custom embedding models, because this was before ChatGPT came out. But what it would do, it was just try to book this ride, and they pretty much deploy all these agents in the Uber app across every single city. And in 4 months, it caught 11 P0 bugs, which equated to $25 million saved in the first 4 months. So then they wrote a paper about it, and then we kind of got a lot of press. And my co-founder got reached out to by a bunch of different companies, like, how did you do this? This is so innovative. So then we spun out of Uber, and now we are creating a company called Revel, which is taking this approach and kind of trying to democratize it and let any company use the same technology. Now AI hype is super real, so there's a lot of people trying to build this. We have our unique take, but I'm going to give you a demo after this presentation. Pretty much the way it works is that you can just write in natural language on the left, and then it will do actions on whatever application you have on the right. And the cool thing about this is that it actually works across iOS, Android, and web. So you can imagine the problem with like Playwright or Appium or XUI tests is that they're built on like XPaths or selector IDs. And here you can say it just says click continue, and the agent will try to find the continue button using kind of the state representation of the DOM and a screenshot, and then it will find that selector ID at runtime and then click it. And this makes it way less flaky. So the reason we call it proactive observability is that we actually correlate all of these test runs using context propagation to the traces that are spat off in your kind of staging environment. So here's just a simple example, but you can see that in that previous one, there'd be like a request hourly button or like a book ride, and then if you used OpenTelemetry, it would create some trace, which is here, which is like, this is like showing an error, and then normally you only get this kind of data in production with like Sentry or Datadog, and then you kind of go through the logs and see what happened, but we can correlate them one-to-one with the agentic test run and the trace. So you can see a test failed in your staging environment. You're like, oh, the booking ride failed. I wonder what happened. Normally, test scripts only show you the front end, and then you kind of have to go and triage it yourself. What this does is you can see the test failed in the front end. I wonder what happened. You can follow the trace through the code and see exactly where in the code it broke. This lets you do super cool things, kind of down the line, you can imagine like auto triaging. You have all that context, throw it into like an LLM or like a O3 call, and then say like try to fix this. Then you can rerun that original test, and if it passed, you actually have pretty high clarity that you found a potential fix. We think this is super cool because it's kind of closing the loop on testing and observability, which wasn't possible before. Some tailwinds that this is a bit outdated, but some tailwinds that we're experiencing right now is that a lot of enterprises are adopting Cursor and Windsurf, and something we're seeing is that these CTOs are kind of worried about reliability in their code bases. All these engineers are getting like, AI code gen tools, and their output is just exploding, and they don't have any way to, maintain the reliability. They're worried about their end users. So something we're noticing is that a lot of enterprises are adopting automated testing more so than before in reaction to these kind of new technologies coming out. Yeah, this slide is just to kind of show that we really wanted to build something that was platform agnostic. What we realized is that enterprises are tired of having different tools across platforms. Normally they have like a QA team for Android, one for web, one for iOS, and they're kind of all scattered, and they all kind of boil up to the CI/CD people who are doing like the platform releases, and like one team might be slow, one team might be good. It's just kind of all over the place. We really see teams wanting to consolidate this into one. Some of the companies we're working with are in the Fortune 100, besides Uber, and we really see the same thing across the board, that there's high test maintenance for all the same reasons that we saw at Uber, that the tests are flaky, there's low signal to noise, and they really are tired of trying to push out releases and just seeing a sea of red on their tests. What this does is it slows down releases a lot, and then ultimately bugs get into prod. And kind of the mission of our company is that users should never experience bugs, especially now technology is getting so good, this is why everyone's here. We're all passionate about testing. We should be able to catch everything in the CI/CD. That's it for slides. I wanted to give you a quick demo of our platform and then just open it up to questions. So here we can see this is just a dummy test account that I created for this presentation. So there's only one test run, but I have a demo on a Sauce Labs website actually. And what's happening here is we're spinning up a headless Chrome browser on the right. And then this is fully interactable. And then on the left here, we have some test steps. And I wanted to show like how they can be very vague. So if you notice here, it's a little bit hard to see because it's a bit small. So it says accepted usernames are, and then there's a list of usernames. And then it says password for all users. And then it says secret sauce, which is a password. And this is interesting because there's just information on the screen. So this instruction step is completely natural language. This is all it is. It says login with the username, the first username in the accepted usernames list, and password on the screen. And if I run this, what it's going to do is it's going to pull the state off of the screen, take a screenshot, figure out what's going on, and then think about the next action to do. And you're going to see here, as this is running, it's going to start inputting the text, and then it's going to know that you should click login. I didn't even say that, but it's just going to figure that out. So you can see it did that. Instruction, add this Sauce Labs backpack to cart. What I'm going to do is I'm just going to run all of these so we can watch this test run. And what happens here is that it's just going to go through the list, do the actions. There's some validations here. This is something I think is super cool because it says, validate the Sauce Labs backpack has been added to the cart. This is just completely with natural language. So what it's doing is it's just pulling the information off the screen, passing it to an LLM, reasoning if it's true or false. And you can do some really cool things with that because you don't need to write anything programmatically. Here we can see it's trying to validate that the backpack was added to the cart, which is true, which I'll show you the results in a second. And then this is kind of a big step, click the green checkout button, fill in the form with this, click this button to continue. These are kind of like, the reason we support steps like this is that sometimes you just want to get through a user flow just to get to an end state. And if something's broken along the way, you're never going to get to that state, so the next validation is going to fail. We find this is pretty useful for kind of like broad spectrum testing. So yeah, you can see here that we got to this final order page. There's a validation that says the order has been dispatched. If we highlight into this once it returns, you can see that it shows you the reasoning. So the order has been dispatched as indicated by the message, your order has been dispatched. So it's just pulling the state off the screen. And then another cool thing that we did was that there's no reason for some of these steps to hit the LLM call every single time. So you can see here, click on the add cart icon in the top right corner, and you can actually cache the input selector, which is here, so that it will happen instantly. It will skip any AI call. It will just, if it's there on the screen, it'll hit it. So what that means is that if nothing ever changes on your app, it will just run through it like a regular playwright test script. But if it did change, which is the problem that breaks these tests, then it will fall back. And that way, it kind of increases speed throughout your test suite. So after a test is run, you get a report created. And in this report, what we do is we just take a screenshot of every single step, because normally you'd have a test suite with a bunch of smoke tests, and they would be like running every single time you put up a PR, and you wouldn't be watching them in real time. But if one failed, you would want to come back and see what happened. So you would click the link in like GitHub on your PR, and then you get this, which is just a screenshot of every single step. Maybe one of these validations failed. You can see like, why did it fail? Then we also give you a recording, which I'll speed up here. But this is just going through exactly what I showed you. And yeah, the super cool thing is that the whole platform looks exact same, regardless if it's iOS, Android, or web, which kind of just creates like a seamless experience for release teams. So yeah, that's the presentation. I wanted to kind of keep it quick and open it up to questions for you guys. See if you guys have any questions. Way back there? Awesome.
This looks really cool. How does Revel kind of spot where like tests are passing when they shouldn't be passing, type of thing? Because like it's modeling everything as it goes and goes, oh, everything's green, but in reality, it shouldn't be.
Yeah. So that really depends on kind of the level of validations that you create. So we can just add one live here. So the thing is, it's always a little bit of like a push and pull with the platform, because if your validations are a little bit too loose, you're right, they might be passing too much. But like, if I write a validation here, there is a red dragon on the screen. And then if we run this should fail, hopefully. And then, so you can kind of write whatever you want in the validations, right? So sometimes we see people that are a little bit too loose with their validations, and that does lead to false positives. But most of the time, this came back true, but that's an error with the response. You can see the reasoning, the condition is not met, which means there is no red dragon visible on the screen. This is in staging, so there is a little bit of bugs, but you can see like that is kind of how you would do it. And the reason we see a lot of other platforms, they won't, like say they'll record your actions and then you'll just kind of do the whole thing and check something at the end. We put validations in, we recommend putting validations throughout the flow, because normally a test fails, it will like break the user flow, so you won't get to some state. So then, say it was trying to say like, is something added to the cart, and we're stuck on the login page, it's gonna fail.
My question here is that I see you're running against a website, right?
Yeah.
How does it work when you're trying to run against an APK running on an emulator or a real device, or an iOS simulator or real device?
Yeah, I can show you really quick here. This is the same. It's the exact same. You just upload your build, and then I can show you one loading up here. So yeah, this has like a app build like for simulators, and then what it's going to do is going to take a second, but this like pops up here, so you can see this is like a real simulator build, and what that does is that, Where
does that simulator run?
Oh, it's
Locally, or
no, it's on our servers. Yeah.
So everything happens on your server.
Yeah. Yeah, so we have a bunch of simulator, just like EC2 instances that run simulators.
Next question would be, does this run in a CI/CD environment?
Yeah.
Okay.
So we recommend people running this in your CI/CD. So you create the tests, and we have like a GitHub action. You just you pipe the ID of the test or like the group of tests into your like whatever GitHub action you want, and then you could say like on every PR coming from staging into main, trigger all these, and then
Okay.
it could block it.
And which oh sorry. Which LLM are you using for the identification of these elements? And is the identification of the elements, you said you're pulling the DOM. How does it happen in the case of mobile device? Is there some OCR recognition as well? And how do you avoid, you might have the same ID, for example. Like, is there some way to validate?
It sounds like social reverse engineering.
Yeah, we're pretty like LLM agnostic. It doesn't really matter. We built the platform so you could just plug and play. We're making a bet that the foundational models are just going to get better. We didn't want to like, we found a lot of even competitors in our space. They would like train their own model or fine tune their own model, and then 2 months later a new model drops and their ones just get smoked. So we always wanted to be able to just use the newest one. So I mean, right now we use a lot of like 4.0, 03. Yeah, it's really kind of all over the place, to be honest. But for web, we look at the DOM and we take a screenshot. For iOS and Android, it's a bit different because there is no DOM. We built our thing on top of Appium for Android, and then we also just pass in screenshots. Although we're rewriting it, we aren't super happy with Appium's performance. And for iOS, we wrote our own driver in Swift. To just, yeah.
Hello, here. Thank you for the presentation, and I think like a lot of the questions that I had were already dropped by the other person. But I still have a question because there are a bunch of workflows that from iOS, Android, or web, you can't really test them if you have like if it's just on your platform. Imagine like we need to test something that requires VPN in our own premises, or if you have to test it locally with some versions of, or even like if we need to test things that we have to disable, imagine like CAPTCHAs or other authentication, and also maybe something related to API calls so that we can actually interact with those. Do you have any vision for that, or do you have any already solution for that kind of scenario?
Yeah, I mean, some of our customers, all their stuff are behind, like, they're all gated, so we need to have like a specific proxy with an IP address that they kind of whitelist, and then that's so you can get around a lot of authentication issues if it's hosted on our cloud. Some customers, this is deployed on-prem, so it's completely in their own cloud, kind of like in their own VPC, so that also gets around those issues. We're working on like an MCP server that you can call through Cursor to test locally, which is pretty interesting, but yeah, there's always kind of like specifics you got to work with for certain people. APIs, we don't really touch them at all. We kind of focus on just the high level of like, you bring us into your CI/CD, and it's just going to make sure the core flows are working when engineers are pushing things. You know, there's lots of like API testing tools that are really good. We kind of just stay out of that. Again, what's up? Oh, sorry.
You showed that you are writing your commands in a human-written language. And if there are many buttons on the screen and there are multiple continues, for example, how it will understand which one to click, and wouldn't it make tests a bit longer if it starts investigating what is on screen and what to click to?
Yeah, I guess if you wrote click continue and there were two buttons beside each other, you would need to specify which one, because it's going to arbitrarily pick a random one based on some kind of confidence interval that's like behind the scenes. So you do have to be a little bit more specific. You can also record your actions, and then it will cache those selector IDs and then pipe them back to natural language steps. So then it would be cached, but yeah, when there's very ambiguous things, you got to just be a bit more specific. We also do support just like JavaScript execution and like hard-coded playwright like steps in them. So if someone doesn't ever want it to hit an LLM, they can just write like a hard script that will just break if anything changes. But people prefer that sometimes.
Yeah. So another question I've seen here right now, these scenarios are all end-to-end, right? Are there any, do you have a plugin or something or a mock server in case you want to run some end-to-mock test cases, or like where you're trying to mock, the responses of your backend services, which you might not have any control on? Or does that mean that it should be implemented on our side?
Yeah, I see. I mean, this is just hitting like, the APK is just hitting the APK or the .app files, hitting that, and then same with the web testing, it's just hitting a URL. So you can set the URL to hit whatever backend you want. You just give us the front end to hit pretty much. And then, so if you want it to be on a mock server, say you like are using Vercel to deploy or something, you can have it set up in Vercel so that every time you put up a PR, it like puts the front end up, and then you could mock that to some random server. So then inherently you would be hitting that. And we see that for mobile tests as well. People will pass in, wow, my computer keeps turning off. They will pass in like specific state into their build that will like hit specific things, like certain flags.
I'm here. Sorry, you can go ahead. Good, thank you. As we went already to technical questions, let me ask more. Couple of things. I see that your solution right now relies on locators, as you mentioned, on like the actual path, while I've seen that there's also like the concept where automated tests like this would be relying on coordinates, like coordinates? Literally X and Y. And the question here is, do you found this more like resistant? What's the benefit of it? The other question would be quite similar to what I'm asking about. As you mentioned about the emulators, for example, for iOS, I know that it's quite difficult to test or like to make the test automation, for example, for Apple Pay. It's under Apple's, those like firewalls. So in emulators, it's not available. Is that also applicable for real devices that you're using, or you're not using real devices at all, and there is a reason also behind of it?
Yeah, our platform works with real devices. We did have a customer using Amazon Device Farm with this on top of it. What we've seen is that Device Farm is just like really bad. It's really slow, and most of the time, like the use case that we get brought into the most is just kind of like smoke test running in your CI/CD, and they want it to be fast, so they don't really like devices, because like sometimes it'll take like 3 minutes to spin up. So they want like fast emulators. For the, and then for the coordinates, I think the thing that's important is just as LLMs get better, we want as much context as possible, and coordinates kind of don't follow that path. If you can throw in like the full state of the app and even like the code and like, the front end state and then a screenshot, like why would you click the XY if you can see the button with the X path? Is kind of our philosophy. Sorry.
Yeah. I wanted to ask, it's kind of like a follow-up to the previous question, and it's related to iOS testing. Because on simulators, you can't really use the camera. And do you have any workflows that actually utilize these? And I believe that you use real devices for that. Kind of like wanted to ask on that.
Yeah, if someone wants to use like a camera, they would probably have to use a real device. Most of the core flows kind of are app specific and not like phone, I guess, like requiring the phone functionality. So normally they'll have like, someone will have some QA person that checks in prod or something like that, or yeah.
Thank you.
Hi, thanks. So you mentioned you support both native apps and web. What about hybrid? Do you support hybrid mobile applications where you have a native app, but it embeds a web view, so you are able to switch contexts?
Yeah, like the web view of a browser app?
Basically, yeah, you have a native app, but it embeds web content inside of it in some parts.
I see. Like an iOS app with a web kind of iframe inside of it kind of thing?
Yeah, kind of like Cordova, or maybe you've heard like capacitor and things like that.
Yeah, if it renders on a simulator, we can click it.
Okay, but what if the HTML contains a canvas element, so you don't have a locator there? Have you thought about a strategy how to interact with the content like that?
Yeah, so we don't normally click XY coordinates, but you can click XY coordinates because you can use, like if you have a screenshot of an app, you can like do bounding boxes around every single thing and then kind of put a label to each bounding box, and then you can have the XY coordinates on the bounding box. This happens a lot with like iframes. I don't know if you guys try to do like test automation with iframes, it's always like a huge hassle, getting some like weird recursive loop going deeper and deeper. So sometimes it's better to just use like an XY coordinate to click on the thing.
Thank you.
There's a couple of hands here.
Hi. My question was, you showed us the example where we can use add to cart and checkout. So for a complex e-commerce website where they have tier pricing or the bundle products that, like, suppose they had 4 products and each product has more than one variant. And in checkout, if it's 2-step and they use Stripe checkout, how much information is like enough information? Like you said that we can write the instruction in a human language, then how much we need to provide to get the results? Yeah, I think you kind of just have to kind of test it. It's very site specific, so maybe like in the front end it might show something, but in the back end all the tags might be the same, so you might have to add like even more context. The cool thing is that you can add like positional logic, so like the red thing to the right of the blue thing would be like very good context, or the second in the list, things like that. It can reason through pretty well. So it's kind of just like you kind of just have to play around with it and see.
As execution environments, are you locked into your platform, or can we connect real devices that are running on our networks? For example, like I have an iOS device or an iPad or something running on my test bench, and then I go to your platform and execute those test cases against this real device.
Right now you're locked in, but it's something we're looking to add. We like just being the automation layer for the execution. We don't really care where it's being executed, but just right now we're running everything on our own simulators.
There's one more question here.
Thank you for your presentation. I have a question about metrics.
Metrics?
Yeah. Do you collect some results? And can you show us maybe what kind of metrics do you monitor?
Yeah, we right now we just have everything like exportable. I showed you like briefly the kind of homepage that has the like results on it, which is pretty bare bones. Most of our companies are enterprises, so they have their own like metrics collection database thing. So what we did, we kind of knew that was going to be the case when we were creating the company. So we just wanted everything to be exportable. Like you could just hit an API and pull everything out. So pretty much people just do that. Most people don't actually look at the dashboard we have. They kind of just build the test and then they run and then they pull it out regularly. But like we don't right now record device metrics. Right now it's like average time that like a test took to run, every single step, what it clicked, if it found a certain path, how many retries did it take, things like that, and then you can kind of track it over time.
All right. One more question.
Yeah, sorry to bother you.
That's why we're here.
What's the architecture with the content that you pass over to the LLM? In the moment when the test is executed, that text gets passed. There's a request which goes to I don't know, OpenAI servers, and then you get back some results, or how does that look? I'm thinking about it like in terms of data compliance or something like that. You don't want to leak to some, I don't know, APIs, your information, your company information, especially if it's like sensitive information like bank accounts or stuff like that.
Yeah, I mean, the nice thing is that most of the time these are in staging environments, so there isn't any like PII in them. It's not like production, so it'll be fake users, which is always a good thing when we're going through procurement. But yeah, I mean, pretty much the state gets like parsed in a specific way, so it's more LLM readable, and then we send it directly to an LLM right before the step executes. So we pass in, the instruction along with the state and the screenshot, throw it all in, get it back, do some kind of reasoning about what we got, and then execute an action. The nice thing is that like OpenAI Enterprise, for example, like you get your isolated kind of tenant of things. So you don't have to really, I mean, some people don't trust them, but like you don't have to really worry about them going out to random API calls because every customer has their own. You could. Yeah, you could. So for on-prem deployments, the API keys are hot swappable. So people will have their own kind of AI center, like with these big companies. And what happens then is like the AI calls like never leave their kind of environment. Awesome.
So, any more? Yeah, there's one more. We can take that. So briefly, you mentioned, the word observability here is kind of represents the ability to connect the backend traces then for understanding where things fail. So do you only work with open telemetry integration just with the backend on, or do you have also some support for real user monitoring for the client traces for services like Datadog and so on?
Yeah, I mean, I think Datadog is built on top of OpenTelemetry. So usually if they're instrumented, we have like our own poller. So all the traces, like if they keep getting sent to Datadog, we can also get them sent to us. So anything that's instrumented, we can pick up.
So both the server side calls and the client side instrumentation. Okay.
Yeah, and like usually OpenTelemetry is best for like microservice architectures. So that's kind of where we get pulled, is like people that have a bunch of services. Because you can see what's going on, and like you can instrument the front end, and, like the traces are good, but where you really get lost is when it's like hitting a bunch of microservices, and then you have no idea what got hit in the call stack. So,
okay, thank you.
I think we had one more question over here.
Do we? Oh yeah,
There's a hand back there. Yeah.
Yeah.
Who was it? You. Hi, Kęstutis.
Hi, thanks. My question would be about the pricing. I was trying to find the price for your product. It's really hard to do.
The pricing? Yeah. For mobile dev, it's $350 a month per parallel run. So you can run an unlimited amount of tests on one device. That's the current pricing we got going. So if you want to run like 5 at the same time, you need 5 concurrent runs. Just because our costs are associated with the emulators that we're spinning up. So that's just kind of the easiest way to pass it on to the customer.
Thank you.
Good question.
As it is typical, then when showing a tool, everything ends with commercials. But thank you, Landseer, for coming.
Awesome.
We really enjoyed the talk and the QA.
Thanks, everybody.
And a little token of appreciation to take back home.